there is a section in the book on both right and non-right. So once you get the book, here's the non-right section where they just kind of collect the formulas and do a brief. And here's the right triangle section, right? So you can review those if some of this is a little wonky. We don't do a lot of non-right, but we will get into them. Like, we'll get stuck. We won't be able to form a right triangle, and we'll have to be able to use both the law of sines and the cosine law. So they give you all three versions of the law of sines. I think really you just have to understand the law of sines and then be able to move these three things around, because these don't really change. They just change based on what's up front. So A is A, B is B. So, and then the sine law. This is important to be able to run also. So those are the formulas for non-right, plus the 180, right? So we have to get, like, we need to be able to understand them and work through them. Because there's going to be, when we get into vectors, there's going to be times where we're going to end up with the triangle like this or like this. So right has a right angle, non-right, that's kind of what I call them. They'll call them obtuse and acute. Obtuse just has a larger than 90 angle, and acute has all angles less than 90. That's supposed to be less than 90. Right? So this is acute, and this is obtuse. I don't really care. Non-right and right is really all you got to like go with, because then that brings in those rules and laws to solve. You still need a labeling system, because the sine law and the cosine law are not going to make sense unless your triangle's labeled. So we still want to go with an A, B, and a C, and then a B, a A, and a C. Get them labeled, whatever you're given, and then apply the laws. The sine law can be written a couple different ways, and they write it with the side on top. The side on top. That's the lowercase a. And then the sine of the angle on the bottom. So A over the sine of A, large case, equals B over the sine of B, and that equals C over the sine of C. So that's a lot of variables, like 2, 4, 6 variables. You never use all three of them. You only use 2. So you either use these 2, right? Or you use those 2, or you use those 2. You don't ever use all 3 of them. You're going to end up with too many unknowns. Okay? And you have to have 3 of the 4 variables. So if I knew angle, angle, and a side, then I can get that side. That's the secret with the sine law, is you got to know enough information. If you write it out and you have 2 unknowns in this one equation, you can't solve for it. You can only have 1 unknown. Unless we're going to go down the simultaneous equation path, which we do at some point just to practice it, but not for a while. Okay? So if you're given information that only gives you 2 things, you probably have to construct or find the third thing before you put it in the sine law. Okay? So just be careful with that. And then the cosine law, they again wrote all 3 forms, and really I think you just got to be familiar with how it works. Again, you've got to have the triangle labeled, so then you can go for this kind of thing. A squared equals B squared plus C squared minus 2, these 2, B, C, and then cosine BC cosine A. And that are the same. So whatever side is here, the angle is here. So this takes some practice to run. Again, you'd have to know B and C and A to solve for that. You got to have enough information.
So the chance funds, usually they're not going to give us cosine of A. We probably have to have.
Yeah, it's pretty rare. Yeah. Usually you're solving for A, and sometimes you're solving for this, which is a little more algebra, right, to move. But it's just addition. This just moves over, this just moves over, this then divides through, right? And you're left with that, and then you got to take the arc cosine of it. So, yeah, it can get a little complicated. All right, so let's do one of these. I'm just going to make it up. I'm going to try and keep it graphically correct. So I am going to label this A, B, and C. And I'm going to give us a side of 40 feet. And this side looks less at 30 feet. And I'm going to give us this interior angle of 107 degrees. So non-right, you need 3 pieces of information. Remember, it's a 4-variable equation. Either way, whether it's sine law or cosine law. Okay? And I want to know C. Side C, and I'd like to also know angle A. So side C and angle A, find. And we know we have these 2 laws to apply. So I'm going to write those so we can look at them. Sine of A, I'll write it upside down, just to show you we can. Cosine I'm going to leave it as theta. How should I do it? I don't want to muck this up. Yeah. That's how they wrote it. I just wrote it upside down. See how you can do that? Either way. They have it A over the sine of A, and I have it sine of A over A. You can flip them either way. So there's that one. What do we know? We know A, and we know B, correct? And then we know angle C here. So we know that, and that, and that. But we can only use 2 of these at a time. So if I try to use these 2, I know those 2, I have 2 unknowns. Right? So then if I go, oh, I want to use these 2, I know that, and that, I don't know that, and I don't know that. So trying to use those 2 doesn't work. So that's why there's 2 laws. Sine law, no, doesn't work. The key to that is called side angle side. If you're given side angle side, that's cosine law. A little trick you can remember. This doesn't work because we can't put 2 together and get 3 of the 4. It just doesn't work. So when the sine law doesn't work, then we have to go to the cosine law. A squared equals B squared plus C squared minus 2BC cosine A. That thing. That has 1, 2, 3, 4 variables in it. If I know 3 of the 4, I can solve for something.
So how do you know what letter goes first? Is it just
So I just wrote the equation in the first form or whatever form I could think of, right? So this is not the form we want because do we know cosine A? We don't know A, right? We know A, we know B, we don't know C, correct? So let's write this in the form of C squared equals, and they gave you that. It's not that tricky. C squared, A squared plus B squared, right? C squared equals A squared plus B squared minus 2AB cosine whatever was here. So if I look at this, I don't know C, but maybe I can find that. Do I know A? Yes. Do I know B? Yes. And do I know the angle C? Yes. So not every form of the cosine law, like this one wasn't going to work. This one does. Because I know A, B, and angle C. These are all just numbers. Calculate your number, take the square root of it, you got it. Don't forget that's a minus sign. Tricky, right? Because the cosine of 107 is what? It's negative. And when we subtract a negative, it becomes positive. So these two end up adding, getting big. We take the square root, it should come back to 56, 58. So be careful with that. You TI users that are using brackets, just be careful with your damn brackets. Should be 5658 feet, which makes sense, right? 30, 40, this should be bigger than 40. That all kind of computes. Took us a while to get to this thing because the sine law didn't work and the first cosine law that we wrote didn't work. We couldn't fill it out. We finally had to realize, hey, we want to find C, 107. We know those two, so we had to use this form. Then to get A, because A was part of it, now I could go back and use the sine law, because I have this, right? This helps me with the sine law, because now I know sine C, sine of 107, and I know this. This is basically a number, and then I can go after A using this, these two. Ooh, man, I used all your time. So I'm going to write that just real quick so you can see it later maybe. But now that I have C, this fills out. I can say sine C, which is this, 56.583496 degrees over wait a second, that's C. That should be on the bottom. 56.58349. That's what I get for going fast. Feet, because it is feet. This is 107. 107. So sine of the angle C, and then the distance below. So that fills out to a number, and then I can use sine of A and distance A. The only thing unknown is angle A. This becomes just a number. 30 feet comes across and multiplies times that number. Take the arc sine, and I have A. So I'm going to write that out. The sine 107 divided by the 56.58. I'm going to put dot, 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 because that's what that means, is it carries on. And I multiply times 30, because that comes across. So it ends up to be the arc sine of all of this. Sine 107 divided by 56.583496 times the 30 that comes across. That gives me angle A. Crunch that real fast. So don't forget to take the arc sine of it. That's easily forgotten. Looks like it should be 30.47. Does that make sense up here? It does, that's a small angle. Graphically, it makes sense. Looks pretty good. The angle's here. Good luck on your homework.